y to the fourth times y to the seventh. If those y's are multiplied and written each time, what do you do with the exponents? So we get y to the 11th power. Okay, second, if you have a power to a power, what do you do with your exponents? Okay, if we are dividing, what do we do with the exponents? Subtract. Will this end on the top or the bottom? The bottom, because we have more y's on the bottom. Okay, so on the bottom, 7 minus 4 is 3. So we have a y cubed on the bottom. What do we put on top? 1. Okay, fourth rule. What does a negative exponent do? Okay, fifth rule. What is anything to the 0 power? Sixth rule. If you have one term, but multiple parts to that, what do we do with our exponent? It goes to all of these. So it becomes a 3 squared, which is 9, a y to the, multiply those exponents. On the bottom, it would become 8 squared, 64. Okay, so the final one. If I ask you to factor, what do you take out? You take out the smallest exponent, so that's y to the fourth. Okay, taking it out is like dividing. Y to the fourth divided by y to the fourth. Anything divided by itself is 1 minus, when I take those out, you're subtracting those exponents, so it'd be 5y cubed. You remember all of those rules? Let's go ahead and extend those to some problems. So the first one, 49 over 144 to the negative 3/2 power. So what does the negative do? Flips it. So then it's a positive 3/2. Okay, how do we rewrite a 3/2 power? What's the square root of 144? What's the square root of 49? So we'll cube those. 12 to the third. And 7 to the third. What? Number 2. If you don't have a calculator, you're welcome to grab one. When all of those x's are multiplied, what are we doing with the exponents? Adding. So we need to do 4/5 plus 2/3 plus negative 1/2. We're just going to get a single x for the answer. Mm-hmm. X to the 29/30 power. And we could write that as a radical, but we don't have to. Alright. Why don't you guys take a minute and try a few examples, and then we'll see how we're doing. So just keep working in these problems. I'll give you a few minutes, see how many. You probably don't have them all done, which is fine. Let's see how we're doing them. So if you just start on this one, you distribute. So 3 times 5 is 15. What do we do with the exponents? We add them. So you have to do 3/4 plus 1/3. Since A is written each time we add them. Okay, then this one we get 6A. So 3/4 plus 2/3. Number 4, b squared to the 0. What's anything to the 0? Okay, the b has a negative exponent, so what happens to it? It goes up to the top, but the 5 stays, so it's b to the 6/5. Right. Next one, if we multiply, -6 times 3 is -18, x to the 3rd times x to the 1st, so that'd be x to the 4th. Y to the 1st times y to the 4th would be y to the 5th. Okay, -18 divided by 9 is -2. Will the x's end on top or bottom? Okay, so 8 minus 4 is 4. We have more y's on top. 5 minus 3 is 2. So -2y squared over x to the 4th. Number 6, we have some options. Typically I found that you guys like to rewrite things without negative exponents. That didn't have to be the first step. You could just go ahead and start subtracting exponents and that will work. So that's perfect, but I think most people usually start flipping. So this x to the -4 would go to the bottom. The y would stay. This x squared would go up to the top. The y cubed came up to the top. So then if we reduce, 5/15 would be a 1/3. We have 2 x's on top, 4 on the bottom, so that leaves us with 2 on the bottom. Y cubed times y to the 8th is y to the 11th. So y to the 11th over 3x squared. The last one. Okay, we say we always factor out the smallest power. What's smaller? -8 or -4? I take out x to the -8. So anything divided by itself is 1 minus. When you are factoring it out, it's like subtracting those exponents. So -4 minus -8 is -4 plus 8. So we get a positive 4 for that exponent. Are those okay? So let's keep reviewing. Talk about reducing radicals next. So I have a 5th root. So we have to look at this, it's all one term, so we can do the fifth root of each piece. What is the fifth root of 32? 2, so 2 comes out. Okay, x to the 12th, that is not going to come out evenly. If you have 12 x's, how many groups of 5 can you make?
2.
How many are left over?
2. Why did I say 3?
Alright, if you have 8 y's, how many groups of 5? How many would be left over?
3.
Second one, square root of 98. Can we do the square root of 98? Okay, so we need a perfect square that goes into 98. What would it be? So the square root of 49 is 7, so a 7 comes out, 2 stays underneath. If you have 9 A's, how many groups of 2 can we form? 4, with 1 left over. If you have 5 B's, how many groups of 2? 2, with 1 left over. Right, on the bottom we have 8 C's, so how many groups of 2? 4. Right, you guys try the next couple of those. So cube root of 64, that's not a perfect cube. What could you break it into? Oh wait, no, it is perfect cube. Sorry, I was thinking fourth roots. I said cube roots, I wrote cube roots, but I was thinking fourth roots in my head. So cube root of 64 is 4. Just making sure you guys are paying attention. You all pass. Okay, the x's, I don't have enough to reduce. So we talked about yesterday, you can't leave a radical on the bottom. It's a cube root, so I need 3 of the x's before I can pull it out. I currently have 2, so we need 1 more. So we're going to multiply by the cube root of x on top and bottom. So that gives us a 4 cube root of x. On the bottom, you get the cube root of x cubed, which is just x. Right. Fourth one. Fourth root of 32. Is there a perfect fourth root of 32? No. But we could break it into 16 and 2. What's the fourth root of 16?
2.
So 2 comes out and the 2 stays underneath. If you have 7 A's, how many groups of 4? That leaves 3 underneath. And if you have 23 B's, how many groups of 4? And that leaves 3 underneath. On the bottom, 4 C's, so that leaves 1 group of 4. And the radical is off the bottom. Final thing, properties of radicals. We focused on this portion more yesterday. If you want to add or subtract, we have to have the same thing under the radicals. So we need to reduce these as much as possible first. So 3 squared is 7, that doesn't reduce. 28, what could we break that into? So the square root of 4 is 2, times 2 is 4, radical 7. Okay, 63, we could break that into 9 and 7. Square root of 9 is 3, times the 4 that's already there, that gives us a 12, radical 7. Now they're all like terms because they all have the radical 7, so you combine the coefficients. So 3 minus 4 plus 12, and that gives us 11, radical 7. All right, second one. What do we have to do here? FOIL. So if I multiply those, 2 times 4 gives me an 8. Square root of 9. Minus 10 radical 3 plus 4 radical 3 minus 5. Okay, square root of 9 is 3, so that's 8 times 3. Negative 10 radical 3 plus 4 radical 3. We still have the minus 5, so then 24 minus 5 is 19. Minus 6 radical 3. Two more. What do I have to do on this one?
Multiply both sides of the fraction by x cubed, fifth root of x cubed.
I have 2 x's. We need 5 before we can pull them out, so we need 3 more. So that would give me a negative 2 fifth root of x cubed on top. On the bottom, you get the fifth root of x to the fifth, which is just 5, or sorry, x. So that's what we were working on yesterday with getting those radicals off the denominators. And last one, what if the denominator is more than one term? What do we do?
Multiply by the conjugate.
So conjugate would be the square root of 5 plus 1 on top and bottom. So if we distribute, radical 3 times radical 5 is radical 15, plus 1 times radical 3 is radical 3. On the bottom, if we FOIL, radical 5 times radical 5 is radical 25. Plus radical 5 and minus radical 5 would drop. Minus 1. I can't break down the square root of 15. I can't break down the square root of 3, but they're not like terms, so we can't add them. Square root of 25 is 5, so 5 minus 1 gives me a 4. Right, so we've kind of reviewed everything from these 2 sections. Do you guys have questions for me? Okay, so if you flip it over, the back side is your homework. So you've got time right now to work on that. What a surprise. I didn't see that.